Alrighty, in this video we are going to be talking about particle motion, or PVA, aka position, velocity, and acceleration. We'll talk about PVA in terms of a particle moving along the x or y axis. So that's going to be the position function. The position function is obviously the position of an object as a function of time t. And we have the velocity function, which is going to be the derivative of the position function. And that's going to tell us how fast the object is moving, whether it's moving left, not moving, or moving to the right, if it is on the horizontal axis. If it's on the vertical axis, then it's going to tell us if it's moving down, moving up, or not moving at all. Acceleration is the instantaneous rate of change of velocity. This is going to tell us how quickly the body speeds up or slows down, aka how fast the velocity is changing with respect to time. So here we have a couple of notation for acceleration. A of t can also be rewritten as s double prime of t, because if I have s of t being the position function, then s prime of t is also the velocity, and then the derivative of velocity is going to be acceleration. Likewise, I have v prime of t, so if I take the derivative of velocity, we're going to get acceleration. So we have s double prime of t, or v prime of t, or a of t. All right, the speed of an object increases, or it speeds up, when it is moving away from the x-axis, and the speed is decreasing when the object is moving towards the x-axis. So here, if my velocity is positive and my acceleration is also positive, then the object speed is increasing. If my velocity is negative and my acceleration is negative, then my speed is increasing. And we're going to look at a graph to see why this makes sense. So here, let's say that this is my v of t graph, right here. Notice how velocity is positive, and if I have a positive slope, this is going to tell me that acceleration is also positive. So notice how it's moving away from the x-axis here in this example. Likewise, if my velocity is negative, let me erase that. If my velocity is negative here, and I have a negative slope, this is going to tell me that my acceleration is negative. And notice how this right here, it's moving away from the x-axis. If I have a velocity where my velocity is positive, but my acceleration is negative, so something like this right here, where v of t is positive, but the slope of v of t is negative, which means that my acceleration is negative. See how my particle is going to be moving towards the x-axis right here. So my speed is going to be decreasing. Likewise, if my velocity is negative and my acceleration is positive, which means that if it looks something like this right here, where I have v of t being negative, but my slope is positive, which means that my acceleration is going to be positive, it's moving towards the x-axis. So that's one way that we can do it graphically. Algebraically, we're just going to be looking at signs. So we're going to be working with those in a couple of examples. Okay, we're going to have a couple of terminology that we'll need to know. So displacement over the interval a to b is essentially the change in position. So where you start versus where you end. Displacement is going to be different from distance traveled. We'll talk about what distance traveled is in the next couple of bullet points. Average velocity is going to be my average rate of change, aka displacement over time. Velocity, of course, is going to be s prime of t, or just v of t. Acceleration is going to be s double prime of t, or v prime of t, or just a of t. Speed is going to be my absolute value of velocity. Speed is going to tell us how fast an object is going, no matter the direction, and it measures the rate at which the position changes. Now, Distance traveled, like I said, is going to be different from displacement. Distance traveled is going to be the sum of the absolute values of the distances between the turning points. We're going to explain why the turning points make sense whenever we do a couple of examples with algebra. Moving forward or moving up means that S of t is increasing or V of t is positive. Moving backward, aka to the left, or moving down if your particle is a vertical particle, means that S of t is decreasing, which means that my velocity is going to be negative. My direction changes when my velocity changes from positive to negative or vice versa. And essentially that's going to be where we set our velocity equal to 0 and then make a little sign chart to see where it changes from positive to negative or negative to positive. A couple of other notes that we need to know, the area under the velocity versus time graph will tell us the total distance traveled. The slope of the velocity versus time graph will tell us the acceleration, of course. The x-intercept on the velocity versus time graph will tell us the object is stopped or reversing direction. So we're going to need those 3 notes and a couple of examples here. All right, so let's look at an algebraic example, aka number 1. So we have a vertical coordinate axis. So this is me moving up and down. So we have a particle moving up and down given by this lovely function right here, where s is measured in centimeters and t is measured in seconds. Part A says find the displacement during the first 5 seconds. So displacement is just where we start versus where we end. So we're starting at time 0, and then we have 5. So I have s of 5 minus s of 0. Well, if I plug in s of 5, I'm going to get 5 to the third minus 9, 5 squared plus 24 times 5. And then if I plug in 0, well, all of this is just going to be 0. So my displacement is whatever this value is whenever we evaluate that. If you evaluate it, you should get 20 centimeters. Average velocity during the first 5 seconds is going to be my displacement over the first 5 seconds, which we already saw from part A, and then my time. So in this case, 5. So 20 over 5 is going to give me 4 centimeters per second. So that's going to be my average velocity. Find expressions for V of t and A of t. So V of t is going to be my derivative. That's going to be 3t squared minus 18t plus 24 using good old power rule. And then A of t is going to be my second derivative of s of t, or my derivative of velocity. That's going to be 6t minus 18. Now notice how I wrote down s prime of t and s double prime of t for V of t and A of t. And that's because whenever we are working with these types of problems, you always want to relate it back to what the function is, aka what they give you. Because they give you s of t, you always want to relate velocity based off of s of t and acceleration based off of s of t. So you can't just say V of t and A of t. You do want to note that, hey, I know that velocity is the same thing as s prime of t, and I know that acceleration is the same thing as s double prime of t. If you don't put that, then points may be taken off because I don't know where you're getting V of t from and where you're getting A of t from. Part D says for what values of t is the particle moving downward. So what we're going to do is think about when is my velocity negative. So that means that I need to figure out when V of t is equal to 0, and I got to make a little sign chart. Based off part C, I'm going to go ahead and factor this. So t squared minus 6t plus 8, that's going to give me t minus 2 and t minus 4 for my critical points of 2 to 4. A critical point is basically whenever my derivative is 0. We'll talk more about critical points whenever we start talking about minimums and maximums in Unit 3. But I have a sign chart at 2 and 4. And what I'm going to do is not plug in values what we're going to do is think about what my velocity graph looks like. Now, my velocity graph is a parabola because it is an exponent of 2. And I know that 2 and 4 are my zeros. Notice how I have a positive leading coefficient right here. So this is going to tell me that my parabola is going to look something like this. Which means that from 0 to 2, my velocity is going to be positive. From 2 to 4, my velocity is going to be negative. And then from 4 to infinity, my velocity is going to be positive. Now, that was a very, 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 very quick way to figure out where my values are positive versus negative. Obviously, if you had a weird function, you're just going to pick an arbitrary value between 0 and 2, 2 and 4, and 4 to infinity, and see if it's positive or negative. So for example here, if I were to plug in, let's say t is equal to 1, I'm going to get 3 times some negative value, because 1 minus 2 is going to be negative, and then 1 minus 4 is going to be negative. A negative and a negative is going to be a positive. Notice how I don't really care about my function value at t is equal to 1. I only care about whether it's positive or negative. Likewise, if I pick an arbitrary value, let's say 3, I should get to a negative answer. So I have 3 minus 2, which is going to be a positive value. 3 minus 4 is going to be a negative value. So that's going to give me a negative, because a positive times a negative is going to give me a negative. Likewise, you could do the same thing for 4 to infinity, but I'm not going to do that. But for now, I'm going to use a shortcut. If I know what the graph looks like, then I'm going to be using what the graph looks like, because that's going to save me a bunch of time instead of evaluating 1, 3, and 5. So for part D, since I'm asking values of t when the particle is moving down, this is when my velocity is negative. So my velocity is negative from 2 to 4. So my particle is going to be moving down from 2 to 4. All right, part E says find the total distance from the particle traveled during the first 5 seconds. Since I'm talking about total distance, I want my endpoints. So I want 0 and I want 5. I also want my turning points, and because that's where I am moving either upward or downwards, and that still counts as distance right here. So I'm going to go ahead and think, okay, find out what my value is for 0, 2, 4, and 5. And since I'm talking about total distance, I want to find S of t. So this is where we're going to plug in S of t for 0, 2, 4, and 5. I already know that 0 is 0, and I already know that 5 is 20. I just need to figure out what's 4 and what 2 is based off of S of t. So once you do that, you're going to get 20 and 16 right here. Since we're talking about total distance, I'm going to be looking at the absolute values between my t values that I changed directions in. So here, from 0 to 2, that's going to be 20. That's going to be negative 4. And this is going to be 4. Then, since I'm looking at the absolute value, I have the absolute value of 20 plus the absolute value of negative 4 plus the absolute value of 4. And that's going to give me 28. What I'm going to do is go to Desmos so that you could see what my particle looks like, and let you guys visually see what is happening here. So here, from 0 to 5, let me do 0 to 5, 0 to 5, it kind of looks like this right here. So x is equal to 0 and x is equal to 5. You'll notice that my particle does change directions, aka it moves downwards from 2 to 4. So it moves downwards. My displacement is where I start versus where I ended, and notice how I go from 0, 0 to 520, so that's going to be a distance of 20. But my total distance, notice how because I went downwards, I changed directions. So I need to have absolute value to account for that distance that I went down from. So I go from 0 to 20, and then from 20 to 16, I traveled 4 units. And then from 16 to 20, I traveled 4 units. So that's why I get a total of 28 units for the total distance for the first 5 seconds. All right, so let's look at number 3 here, where I have a graph and it is showing the velocity function. So here, part A says, when does the particle move forward and when does it move backward? So the particle is going to move forward whenever we have my velocity being greater than 0. So my velocity is positive. In this case, my velocity is positive from 0 to 3, and then 5 to 8. So that's forwards. Now, if I'm going backwards, that means that my velocity is negative. So that's going to be from 3 to 5. All right, part B, when does the particle speed up and when does it slow down? So just like the graphs that I showed you right here, we know that if my graph is moving away towards the x-axis, then I know that I am speeding up. And if I am moving towards the x-axis, then I know that I'm slowing down based off of my velocity and acceleration being the same signs or different signs for part B. So I'm speeding up whenever I'm moving away. So I'm moving away from 0 to 1. So I'm moving away from 3 to 4. And then I'm moving away from 5 to 6. Speeding up. Slowing down, I'm moving towards the x-axis. So I'm moving towards the x-axis from 2 to 3, 4 to 5, and then 6 to 8. 2 to 3, 4 to 5, 6 to 8. Part C says, when is the particle's acceleration positive? So when is my slope positive? And when is my slope negative? And when is my slope 0? Because we're talking about acceleration here. So here, whenever we're looking at this, I know that I am positive here and here. So that means that my acceleration, aka v prime of t, because they give me velocity, is positive at 0 to 1 and then 4 to 6. Acceleration is negative when v of t is negative. And that is when we have 2 to 4, 6 to 8. And then last one, my acceleration is 0 whenever I am constant. So that's going to be from 1 to 3. No, 1 to 2. And then 8 to 10. So v of t is constant. Let me rephrase this. V prime of t is increasing, which means that my velocity is positive. V prime of t is decreasing, which means acceleration is negative. And then v prime of t is constant. That works. Because obviously v for most of this, v of t is going to be positive right here. Let me rephrase this again. V of t is increasing so that v prime of t is positive, aka a of t. Okay, that's much better. Sorry, guys. Constant. That means that a of t is 0. All right, part D says, when does the particle move at its greatest speed? Since we're talking about speed here, we're just going to be looking at the absolute value and seeing where my maximum is. So here, my maximum here is at 2. And you'll notice that if I do the absolute value, this is also going to hit 2. So this tells me that my particle moves at its greatest speed from 1 to 2, 4, and 6. Part E says, when does the particle stand still for more than an instant? That's going to be from 8 to 10, because I am sitting still for 2 seconds right here. Alrighty, so in the next video, I explain number 6, so you guys can also look at that. After that, we are going to be talking about product and quotient rule. So that's going to be a lot of fun.